there, I'm Nick Culinary. I'm the Center Director here at the Flexible Electronics and Display Center at Arizona State University. We're running basically a pilot manufacturing facility for flexible displays. We've been doing this for a little over 10 years now. We're all about changing the way that electronics are made. This looks like a conventional piece of thin, flat, and hard electronics like you might buy in the store, but actually it's a thin sheet of plastic on a piece of glass. The plastic has got electronics on it, and after we finish making the electronics, we peel it off, and we have something that's foldable, rollable, crumple-upable, just like a piece of plastic, except it's got electronics on it. So we're trying to enable the wearable electronics revolution by figuring out how to make this stuff. Over here, we've got a robot tool that is doing one of the process steps for making this stuff, where we actually coat a couple of different layers onto that sheet so that we can assemble the full electronic part. Both what we call an interlayer dielectric, one of the actual active layers in the structure, and a layer that is just part of the manufacturing process. Polymerizable material that allows us to create a stencil that we can use to pattern different materials on the substrate. So the robot comes in over here and grabs a panel, sticks it in an oven to do something we call pre-baking, and then drops it down into this receptacle where the other robot arm has a shower head on it that's spraying material. The material is dispensed in such a fine shower mist that you can't actually even see it unless you look really carefully. But when it's done, we've got a thin layer, about a 25th the thickness of a human hair, on the surface of that glass panel. And we've got the next step in our process completed. As I said, we've been doing this for about 10 years. This is part of a large Army project where we're figuring out how to engage in the manufacturing of technologies useful to the U.S. Army that are mostly, as we all know, we hear about it all the time, made overseas. But some of these niche products are still manufactured in various corners like this here in the U.S. In a kind of a network of companies that are interested in the technology space and that have capabilities like we do. Right now, we're actually not making displays. We're making flexible X-ray detectors that are used for checking to see whether or not suspicious lumps in the road are going to explode and kill people. Hi, I've moved down to the other end of the fab next to the developer tool. The process for making these electronics is basically a step and repeat process where we put down a material on the panel, on the plastic on the panel actually. We perform a series of operations to pattern that in a microscopic pattern, and then we put a new layer of something else on top of that, do that sequentially 4 to 8 times to make a three-dimensional structure that's the electronics that we're trying to make on the plastic sheet. Down here at the developer, we're actually removing one of the materials that is put onto the panel during the process in order to help us with the patterning, the photopolymer that I talked about down by the coating tool at the other end of the fab. Once the photopolymer has done its job as effectively a stencil to mark the areas of material that I want to selectively remove, I have to take that stencil off to get ready to put the next layer of material down. We've just finished developing this panel that's on the spinning bowl, and so the robot has come to collect it and stick it in the staging area to be ready for the next process. After that, it'll grab another panel. It's going into the drying oven now. And now it'll come out and grab another panel to develop the next one. Swings around. These tools were purpose-built for us by EVG. You see their logo over there on the edge of the tool. EV Group is an Austrian semiconductor manufacturing equipment company, family-owned firm. Their North American headquarters are right here in this facility with us. We work side by side with their engineers. These tools were developed in collaboration with them. It's part of our model for how we interact with industry to develop specialized technologies to fulfill our mission for the U.S. Army. So the panel has now been positioned in the spinner bowl. It's being dropped down so that we can get it spinning around. And we've got another arm that's going to come over with a series of syringes that are going to dispense some specialty chemicals to do the removal process, and some protective sides have come up. And we're back where we started when we started filming this spot. Okay, so now I've moved over to another part of the fab. This isn't normally where we do this, but I wanted to show you the last step in the manufacturing process of the flexible electronics. So we've got a completed part here, and my helpful assistant Nick Muziza, one of our engineers here in the fab, is going to show you how we actually just peel it off the glass when we're done. So we've got a couple of X-ray panels that have been completely finished on the glass panel. And Nick, why don't you go ahead and show us how you peel this off. It's as you'll see, it's a deeply involved and complex operation. He's got a bar there attached to one side of the plastic, and now just with a little bit of force, he's just gently lifting. Doesn't really involve very much pressure at all. That's really the secret to this whole process. People have developed a bunch of different ways to get the plastic off. Blasting it with a laser, or using special layers that help them remove it. But we've got a special process that we've developed here. It's certainly one of the leading state-of-the-art approaches to this, where it just comes clean off. You can see now we've got about half of the part off of the glass panel. Well, closer to maybe a quarter or a third. But if you look carefully, you can see that at the spot where the plastic is still attached to the panel, there's a fairly tight little bend right in the piece of plastic between the still on the glass and already off. Gives you a sense of just how flexible this stuff is. The plastic sheet itself is about 25 microns thick. I think 25 microns thick. That's the thickness of a human hair. And that's what gives it that tremendous flexibility, the ability to be integrated right into clothing, or into something that you can wrap around your wrist or put in your eyeglasses, or anything else that anybody's thinking of doing with flexible electronics. We're almost done here. That's amazing steady arms. Coming right up to the end here. We've got the two X-ray panels in the center, and then around the side you see a lot of other small parts. Those are mostly test electronics that we use to monitor the process, to help us dial it in and make sure that everything's operating the way it's supposed to. And now the critical moment, you can see as it comes free, it's so thin, it's starting to curl up. Can we, use your hands to just extend it. You see what we've got is two X-ray panels made on a piece of plastic, so flexible it's bending itself. We just get our hands in there and gently extend it to flatten it out, and ready for integration into the rest of the system. That's the active guts of a flexible X-ray detector. So I'd like to thank you for coming by and visiting us today and seeing what we're all about. We're very excited about the work that's been going on here right in Phoenix, Arizona, one of the leading centers for research in the manufacturing of flexible electronics.